All right, everyone. So let's do some of these problems here to practice our quantifier rules. I should suggest that you have your quantifier rules around you while you're watching this video or doing these homework problems. You might also want your other rules around, your inference rules and your replacement rules, but really those other ones should be pretty memorized by now. So inference rules and replacement rules, those should kind of be understood. We really are working on quantifier rules now. So let's begin here by looking at these problems. Number 2 in particular is the set we'll be looking at. And in these problems, I think they're really interesting because they basically made a mistake on purpose, right? And your job is to identify it. So I like this. Take a note of that for the test. So what's going on here is that we just have to find the line that has an illegal move. So, well, obviously the assumptions check out. Those are clearly sentences of PL. There seems to be no errors there. So, okay, let's continue here. Line 3 is where I see something fishy. So if you look at the schema for the universal elimination rule, it shows you that you can go from a universally quantified sentence. I mean, it literally says this. So here's the schema. And it says if a sentence has a universal quantifier as its main operator, you can go ahead and replace. Essentially, you just put a sticker, an individual term, you put it over the variable. So that's the way you kind of want to understand that. And so if we're looking at this problem, well, here is the main issue. They allegedly went from number 1, right? So they're saying that they did universal elimination on that, but this is wrong on at least 2 different levels. The main operator here is not the universal quantifier. It's actually the horseshoe. So this rule, you can't even use it in this context. You need the universal quantifier to be the main logical operator. Moreover, I mean, you know that it's not okay to just basically take out the antecedent of a conditional. There is literally no rule that allows us to do that. Modus tollens comes the closest, but you need a tilde on there. So number 3 or line 3 is definitely the illegal move. There's actually at least 2 things wrong with that inference. So that's the first one, or A, I suppose. Let me erase this. Okay, so number 2, it looks like, again, we can basically check those off. Those are regular sentences of PL, nothing fishy there. Let's look at line 3. K has a property of M, or MK. Well, they say that's universal elimination from line 2. And remember that what universal elimination means is literally everything has a property M. So if everything has a property M, well then guess what? K has the property M. So that is a legal inference. That's definitely okay. All right, let's continue then. Line 4 is 1-3 conjunction introduction. Well, that looks legitimate too. You just took lines 1 and 3, put them together with an ampersand. That's fine. Okay. Line 5, universal introduction from line 4. Now, there's a couple of things that we need to do before we can actually do a universal introduction. We need to check that the individual term that we're eliminating, which in this case is K, that's, not the ampersand, it's K. We need to make sure that as that is being replaced with a variable, that's X, right? That's what it turns into. There's a couple of things that we need to make sure of. Number 1, K cannot occur in an open assumption. What does that mean? Basically, it can't appear over here, right? Or if you have any subderivations, it shouldn't be in here either. But there's no subderivations here. In any case, so the very first thing you have to check for when doing universal introduction is that the individual term that you're getting rid of doesn't appear in the open assumptions. By the way, K is right there. So right away, you know that you can't use, you can't do universal introduction on this line. So technically then the line that's illegal is line 5. So that's that one. Okay, let's look at the other ones. Okay, let's look at C now. These check out, obviously those are fine. Ooh, this is the problem pretty much right away, right? Existential elimination, if you look at it, it is a subderivational rule. You begin with an existentially quantified sentence. By the way, when I do double, that means it's bold, right? Then you do a substitution, right? An instance of that existential quantifier. And then you derive some sentence Q, and then you move that sentence Q back to the main scope. Everything always has to end on the main scope, right? So here, there is no subderivation, and so that's what's wrong with this. So line 3 is the error. Technically, though, I might add that there should be a line 7. Even if you were to add the subderivation, you'd have to once again write Q appears at the end of the subderivation and then again on the main scope. So you'd actually have to get another, let's pretend it's right underneath the main scope here. You'd still have to write this on the main scope. And then you'd have to say, what is it? Line 1, 3 through 6, existential elimination. So that would be the actual complete proof. So there's technically 2 mistakes in this one. Line 3 should be a subderivation or the beginning of a subderivation. And there should be another line after the subderivation, line 7. So those are the mistakes in that one. Okay, let's take a look here at number 2 now. So obviously the assumptions check out. Those look like perfectly valid sentences of PL. So let's look at number 3 here. It is an assumption for an existential elimination, and that is actually where the mistake is. So why is this? Well, I redrew here our schema for that rule. And in a way, existential elimination is the most powerful rule. I mean, you can do basically anything with it. But there's actually 3 desiderata. Well, I shouldn't call them desiderata. They're criteria. You need to meet certain requirements before you can use existential elimination. And what are those requirements? Well, as you are moving, so this is so let me use blue here. So what the rule essentially is moving from an existentially quantified sentence, that's that one right there, right? That's the main operator, to an instance of that existentially quantified sentence. Basically, you replace the variable, which would be X, with some individual term, right? So A would be the one in this case. By the way, A literally is the one we're using if you look at number 3. So, and then you go from that assumption to some desired sentence Q, then you end the subderivation, and then you rewrite Q back on the main scope. So that is, in a nutshell, existential elimination. So it's very, very powerful because Q can be anything. I mean, you can basically conclude, as long as you follow the rules, anything you can conclude there, you can move it right back to the main scope. It's very, very powerful. But there's 3 things that you need to make sure when you are using existential elimination. So what are those 3 things? Well, first of all, A, and it, by the way, it really is an A in this case, right? So that makes it easy to talk about. A cannot occur in the open assumptions. So what does that mean? Well, it can't be in the premises, and it can't be in any open subderivation, right? So actually, it turns out it checks out here. A does not appear in those, and there's actually no open subderivation besides the one we're working on, but that one doesn't count, right? So, okay, so we meet the first criteria. Second, A does not occur in the existentially quantified sentence that is basically launching your assumption. So in this case, this sentence that we are using as an assumption, that came from this existentially quantified sentence. So we need to make sure that A doesn't appear there. By the way, again, we're good. There is no A in number 2. So we already knew that because we had already checked the assumptions, but still, sometimes the existentially quantified sentence that you're using to launch your subderivation isn't actually in the assumptions, right? So, okay. And the third criteria that you need to meet before you can use existential elimination is the following. A does not occur in Q in the target sentence, that right there, or at the end too. Well, the target sentence in this subderivation is line 5. But clearly you can see A is right there. So the illegal move is line 3 because you may not use A as your individual term there because it appears in the target sentence, which essentially makes it, a little too easy. Let's just say that. It's an illegal move. So that is why line 3 is illegal. Let's just check to see if the rest of it is good though. Once you do have that, you technically, this is fine. Let's see. Yeah, that's fine. That's fine. I mean, I guess that's sort of fine. As long as we acknowledge that this line is not okay, that I don't know. I'm kind of confused as to whether to call that legal or illegal, but let's just leave a question mark then. But everything else checks out. So, so definitely line 3 is the main mistake there.